Welcome back to another video, and today we are talking about digital signatures. In lockdown, a lot of companies have been sending around a lot of documents saying sign this, sign that, sign something else. And what people have been doing is writing their signature on a piece of paper, taking a photo of it, cropping the photo and inserting that as an image into a word processor document. Or writing their signature on a tablet and inserting that as an image into a word processor document. Now, there are obvious problems with this. The whole point of a signature is to attach you to a document, to associate you with something and essentially say that you've read it and agreed with it. But if anyone can get hold of that image, which they could do, they could copy paste that into any document and associate you with that document. Now, to be fair, a bad faith actor will always be able to do that with whatever approach we use. But a wet signature, so in other words a signature that has been written in ink on a piece of paper, it's more difficult to do that because you would need a forger and you would need a fingerprint expert to lie. So if you're not there to say, yes, that's my signature, someone behind the scenes, a bad faith actor, could lie and pretend that you had signed that document when you hadn't. But it would be more difficult to do than with the image inserted into the word processed document. Now, a digital signature is an attempt to recreate some of the advantages of the wet signature without actually having paper, without actually having anything physical, a pen or a camera or anything like that. How to do this? Well, as a first approach, what we could do is we could take a name such as Jonathan and we could run it through an encryption algorithm and turn the text Jonathan into some gibberish and use that gibberish as a signature. Now, if there are some graphics on the screen right about now, then yes, this channel now has graphics. And if there aren't graphics on the screen right now, we'll do a cut here and go and think of something else. Or if there are graphics on the screen here, but it was way more effort to put them here than I thought it was going to be, then we'll have a cut here and go and do something else. Now, if you always sign your documents Jonathan and run Jonathan through the same encryption algorithm, you will always get XCKANHBT. So you'll always be putting that at the bottom of your documents, and we haven't solved anything. Anyone could come along and type XCK, etc. at the bottom of any document and associate Jonathan with that document. So instead of that, what we might do is we might change it so that each signature is unique. So here Jonathan has changed his signature message to be specific to the document that he's just read. So Jonathan has read Doc 1234 and signed it Jonathan read Doc 1234, and we've got that encrypted. And now Jonathan will be able to decrypt that gibberish and demonstrate that it actually says Jonathan has read document 1234. Now, this is a big improvement, but we still need Jonathan to be around to decrypt his signature and prove that he was the one that actually signed it. Without him and his private encryption keys, we won't be able to tell whether or not that's actually Jonathan. And a bad faith actor could still come along with a piece of software pretending to decrypt it and maybe decrypt it as this, document 1234 approved by John, and pretend that Jonathan had actually read and signed the document. So we still need Jonathan to be there to decrypt the gibberish with his private key. So what we really need is some way that Jonathan can sign and prove, if he needs to, that he signed, but also the person who's reading the document that Jonathan has signed, we need them to be able to know that Jonathan was the one that signed it. And the way this works with digital signatures is by using a version of public key, private key encryption. Now, public key, private key encryption works by having a key that anyone can get hold of. You could publish it in the New York Times, and anyone can use that to encrypt a message, but the owner of the private key is the only person who can decrypt it. And we've spoken about this before on this channel, but it involves one-way mathematics. So if we take our old friend the clock, here he is. If we send into a clock a number such as 14, the hour hand will move around from 12 14 times and end up pointing at 2. So the output will be 2, but there's no way to work backwards from that to know that the input was 14, because the input could have been 26, or the input could have been 50. Both of those numbers will produce 2. And this is an example of one-way mathematics. Now, a digital signature takes this idea and turns it on its head. So here we have a private key that is used to encrypt and a public key that is used to decrypt. So Jonathan uses a private key that only he knows to encrypt his digital signature message, puts that on the document, sends it to whoever needs it. Now, if they need to verify that Jonathan was the one that actually signed it, they can run Jonathan's encrypted gibberish through the public key and verify that plain text, something sensible in plain text, comes out the other end. Now, I've got an example here of some software that you can use to do this. And it's open source, and here we have another example of how brilliant open source software is, because now we have a situation where we've got some software that I'm about to show you that has been written and published, and hundreds of highly technical people have combed through the code and made sure that it is correct. So here, if a bad faith actor comes along and pretends to decrypt Jonathan's message and pretend that it produces something sensible with some charlatan code, any one of these technical people can step up and accuse them of their deception. So their deception will likely be discovered. Okay, so here it is. The package that we are going to use in R is called Sodium. We load it up with the library command, and then the code that Jonathan needs is here. So the first thing he does is create his private key with the sig keygen command. Let's have a look at it. That's his private key. That's something that he has to keep super secret. And he uses that to generate a public key. And that's what the public key looks like. Then his plain text signature I've got here is Jonathan Doc 1234. So that's his plain text, and to turn that into an encrypted signature, he uses the sig sign function. Let's have a look at that. That's what it looks like. And that gets copy pasted to the bottom of his document. And then when someone needs to verify that it was actually Jonathan that signed the document, they run the sig verify command. Now, to run the sig verify command, they need the public key, which Jonathan created. They need the signature, which is at the bottom of the document, and they also need the plain text message, because what they're going to do is verify that those two match. And that's okay. They can have the plain text message. There's no problem with that. It's not secret. And the only thing here that's secret is the private key. And if they run that function, it says true. So it is true that Jonathan signed this document. So there it is, digital signatures. And if you like these videos, subscribe down at the bottom somewhere, and I will see you in the next one. Bye bye.